Hey, it's Marco, and this is my Unit 3 summary. To begin with, we'll be talking about Module 6, which was examining distributions. A categorical variable are qualitative data in which the values are assigned to a set of distinct groups or categories. Examples of this would include a ball, or colors of a ball, a breed of a dog, and to summarize the distribution of this categorical variable, we create a frequency distribution table, which I will go over later. There are two ways to display categorical data, which is the pie chart and the bar chart. Pie chart emphasizes how the different categories relate to the whole, while bar chart emphasizes how the different categories compare with each other. Quantitative variables are variables that represent a measurable quantity like height and test score. There are two ways to display quantitative variables, which are a histogram and a stem plot. You use a histogram when the data is numerical or quantitative, and you want to see the shape of the distribution. It is important to note that each observation should only be counted once in an interval. A relative frequency table can be used to determine the frequency of something happening across intervals. To interpret a histogram, you want to look for shape, center, spread, and outliers. For shape, look at the symmetry and skewness of the graph and the number of peaks. When a graph is skewed right, it shows that smaller/medium numbers are much more frequent than larger numbers. When a graph is skewed left, it shows that larger/medium numbers are much more frequent than smaller numbers. There are three main measures of center: mode, mean, and median. Mode has to do with the frequency, mean is the average of the observation, and median is the midpoint. Mean deals with the actual values, and median deals with the order. Mean is sensitive to outliers, while the median is not, which makes median a more reliable method to measure center. There are three measures of spread: range, interquartile range, and standard deviation. Range is the distance between the max and the minimum. IQR, or interquartile range, measures the variability of the middle 50% of the data. The 5-number summary is used to provide a quick numerical description of center and spread for large datasets. IQR is seen as a better measure of spread than range because it's resistant to outliers, and it can also detect outliers while using the 1.5 IQR criterion as shown below. Box plots display the distribution of quantitative variables using the 5-number summary. And side-by-side box plots are used to compare the distribution of two or more groups. Outliers are data points that fall outside from the overall pattern of a distribution and need to be researched before making a conclusion. Standard deviation measures how far observations are from their mean and is influenced strongly by outliers. This also shows how much data is grouped around the mean. The empirical rule is used to anticipate probable outcomes in normal distributions, and it's a good way in forecasting data. Stemplot is a simple way to visually display quantitative data. We will be now moving on to Module 7, which was examining relationships. In this case, the explanatory variable is categorical and the response is quantitative. To interpret this, you want to construct side-by-side box plots and compare the spread, IQR, and the median between the extremes of the data. For categorical explanatory and categorical response, you interpret this by creating a two-way table or contingency table. For numerical summaries of the data, conditional percentages are a good way to highlight differences. These percentages can be in rows or columns, which is indicated by wherever the explanatory variable is. For quantitative, the appropriate display for this relationship would be a scatter plot. This is a good way to observe the correlation between the variables. To interpret the scatter plot, look at its direction, form, strength, and if it has any outliers. The correlation coefficient R is a numerical measure of the strength and direction between the two quantitative variables. When R is less than 0, the data is negative. When R is greater than 0, the data is positive. The closer you get to 1 or -1, the stronger the correlation is. However, these values are heavily influenced by outliers. Linear regression is the best fit line for a data set, which is basically like the slope. So this is used so that we can predict the value of the response when given an explanatory variable. When we see a relationship that changes, we usually conclude that the explanatory changes the response. This leads people to believe that there is a causal relationship between the two, when there might just be an association between the variables. The association might be a result of a lurking variable, which is a factor that could affect the interpretation between the explanatory and response variable. Simpson's paradox occurs whenever we include a lurking variable in a study, which then causes us to reconsider the direction of an association. To avoid this, we need to separate the data into groups or combine them. Thank you for listening to my Unit 3 summary.